A plane flies horizontally at a height of 300 meters above the ground. Its speed is 200 meters per second. At what horizontal distance from a target should it release a bomb so that it hits the target? So, this is our problem. The bomb falls in a parabolic path because there is no air friction in this problem. So, how do you solve a problem like this? So, as always, we set up a coordinate system, x-axis to the right, and I will take y-axis upwards. You can take it downwards if you like, it doesn't matter. So, let me take x and y. And as usual, we separate the motion in the x direction and the y direction like so. So, in the x direction, in the y direction. The initial velocity of the bomb in the x direction is the same as that of the plane. Because when the bomb is released, it was at rest with respect to the plane, so it was moving with the same velocity as the plane. So this is also 200 meters per second. And since the plane was flying horizontally, uy is 0. As usual, ay is 9.8. We will take it as 10 meters per second squared downwards. Since I have taken y pointing upwards, it is minus 10 meters per second squared, and acceleration's component in the x direction is 0. So our question is, we need to find Sx, the horizontal distance from the target when the bomb is released. What about Sy? Sy is minus 300 meters. So let's write down the equation for Sy. Minus 300, S is equal to ut plus half a is minus 5 t squared. So t is going to be equal to root of 60 seconds. During this time, how far does the bomb fly horizontally? So Sx is equal to ut plus half a t squared. A is 0. So this is the answer. So many meters. We can simplify this further, but I'll leave it as it is. Before I go on to the next problem, let me point out something very interesting. Supposing the plane continues to move at 200 meters per second, the bomb's horizontal velocity of 200 meters per second doesn't change because there is no acceleration in the x direction. So at all times, the horizontal displacement of the bomb and that of the plane are going to be the same. So at all times, wherever the plane is located, the bomb will be directly beneath it. So when the bomb lands on the ground, the plane will be directly above it unless the pilot takes evasive action. So if you're a pilot and you're going to drop a bomb, after releasing the bomb, take evasive action. Otherwise, the bomb is going to explode right beneath you. Now let's go to the next problem, which is different. In this problem, a plane is flying at 200 meters per second, making an angle of 30 degrees with the horizontal. It's not flying horizontally. At the instant that it is 200 meters above the ground, it releases a bomb. So the bomb also has the same initial velocity. The question is, where does the bomb land? That is, at what horizontal distance from the point of release does the bomb land? In other words, what is the horizontal displacement of the bomb? The question that was given to you is, at what horizontal distance from the point of release does the bomb land? So when you make a drawing, you can see immediately from the drawing, this is nothing but Sx. So as always, we'll set up our coordinate system, x-axis horizontal, y-axis vertically upwards, and let's set up x and y separately, x and y. So initial velocity of the bomb in the x direction is 200 cos 30. Cos 30 is root 3 by 2, so that becomes 100 root 3. Y component of the bomb's initial velocity is 200 sine 30. Sine 30 is half, so that is 100 meters per second. As always, ay is equal to minus 10, ax is equal to 0, and we know that sy is minus 200. That is the vertical displacement or change in the y coordinate of the bomb. The fact that it went up and then down doesn't matter. S stands for displacement. So minus 200, S is equal to ut 100t plus half at squared minus 5t squared. So that gives us time of travel for the bomb as approximately 21.8 seconds. So let's take that and put it into the Sx formula. Sx is 100 root 3 multiplied by 21.8. That's your answer. Of course, you can go ahead and simplify that. I'm going to leave it like that. Now in this problem also notice something interesting, which is initially the plane and the bomb have the same horizontal component and the vertical component, but we are interested in the horizontal component. So at all times, the horizontal displacement of the plane is going to be the same as that of the bomb. So when the bomb is here, its horizontal displacement is this, and the plane is somewhere out there, its horizontal displacement is going to be the same. So at all times, again, the bomb will be directly beneath the plane. So again, if you're dropping a bomb, release the bomb and take evasive action. In the third problem, we have a moving target. So the target is moving at 30 meters per second horizontally. The plane flies horizontally at a height of 400 meters. It's moving at 300 meters per second. At what horizontal distance from the target should it release the bomb so that the bomb goes and hits the target? Now the easiest way of doing this problem is getting into the target's frame of reference. In the target's frame of reference, it becomes a stationary target, and in this frame of reference, the plane's velocity is 300 minus 30, which is 270 meters per second. So it becomes a problem where the target is stationary, the plane is flying at 270 meters per second at a height of 400 meters. How far away from the target should it release the bomb? So let's do this problem in the target's frame of reference, where the target's velocity is 0, the plane is moving at 270 meters per second. So as always, x-axis to the right, y-axis pointing up, and let's separate the motions in the x and the y directions. As far as the bomb is concerned, its initial velocity in the x direction is 270 meters per second. Its y component of its initial velocity is 0. Acceleration in the y direction is minus 10. Acceleration in the x direction is 0. Displacement in the y direction is minus 400. And therefore, S is equal to ut plus half a t squared. So right away you get t is equal to root of 400 by 5. So that's going to be root of 80 seconds. That is the time of travel of the bomb when it comes and hits the target. So Sx is going to be equal to 270 multiplied by root of 80. This is your answer in meters. Now let's do the same problem in the ground frame of reference so you get an idea of how to do this problem in two different frames. Now again, I keep mentioning the secret to doing a physics problem is a drawing. So let's see what happens in the ground frame. In the ground frame, the bomb is released at the right distance from the target, but during the time that the bomb is falling, the target is moving. So let's say the target moves from here to there, which means by the time the target arrives here, the bomb has come and hit the target. So let's say the time of travel is t. During this time, the target is moved a distance of 30t. And our job is to find the distance, or I'll just call it S, the distance from the target when the bomb was released. So the total horizontal displacement of the bomb is S plus 30t. You see, the equations come out from the drawing. So always make a drawing. Again, when the bomb is released, the target is at a distance of S. During the time of travel, the target moves a further distance 30t. So the bomb should travel a distance of 30t plus S in the horizontal direction. So as before, Sy for the bomb is minus 400, x and y. As before, y is upward, x is to the right. Ux is 300 in this frame. Uy is 0. Ay is minus 10. Ax is 0. So Sy is minus 400, S is equal to ut plus half a t squared. So t is root of 80, and the time of travel should be the same in both frames of reference, so not surprising it is root of 80. And we have the equation Sx is equal to u t plus half a t squared. A is 0. So from this we get S is equal to t, remember, is root 80. So 300 root 80 minus 30 root 80. So that is equal to 270 root 80. Same answer that we got in the other frame of reference. That's it for this video. Bye until next time.